Okay, so review the how to derive the table from the diagram.
So you set up the current state, and then you're going to actually carry that, and then go down the table, not fine, that's fine.
Yeah.
You're seeking out more information after.
Right. How did I do that? Yeah. Okay, so let's take a look at this. So highlighter up here. Generating the combination of states with event condition pairs is clear, right? That's just all possible combinations of states with event condition pairs. So I got this list here and I got this list here, and what you do is you just say, okay, browsing with all of these and then selecting with all of these and so forth, right? That's just a copy-paste operation if you're doing this in Word or Excel or something. Now, action and new state, where did that come from? Well, that came from the original diagram, right? So if I look at the state and the event condition combination defined in the first two columns of the row, if there is a defined transition with an associated action perhaps, and certainly a resulting state, then that gets populated into the action and new state cells in that row. If there is nothing defined, there is no transition that corresponds to that, then that's why I put the undefined here. Okay, so that it's basically a two-step process. First thing you do is you generate these columns here, which is just a methodical combination of the set of states and the event or event condition pairs. Then you go back and refer to the table, marching pretty much methodically through the different states, right, starting in the browsing state and then looking at the event or event condition combinations in each row, and ask yourself, is that associated with a defined transition or not? If so, what's the action? What's the resulting state? If not, undefined. Does that make sense? Okay, good. Yeah, it's a completely mechanical process at that point. A lot of this stuff is, which helps, makes it easy because then you just follow the process and get to the desired result. The thing that's complicated about the state transition tables then is, it's not really complicated, it's just potentially time-consuming, is generating all of the test cases. Now, if for some reason you have to write them down, then that's going to be pretty tedious because you're going to have a big long list. But if you don't have to write them down, of course, you can just use the state transition table directly, having generated it, right? You run through your standard tests, if you will, and just look for opportunities to inject some of these weirdnesses into it, right? And if nothing untoward happens, then you say, okay, well, that's fine. Otherwise, it's a fail, you report the bug, right? So you don't necessarily have to create the written tests for this. This by itself, this table by itself, in combination with the predefined tests for the just basic state transition cover is probably sufficient. That's probably also true of the switch table, too, that once you've defined the switch table, you actually wouldn't have to create written tests corresponding to it so much as just augment your existing written tests to try to force those additional transitions. So that would kind of minimize some of the paperwork. Other questions? Well, I'll let you think about it. In the meantime, I've got a couple that came in via email here, so I'll handle those. Feel free to jump in. I'll also go to the audience here in a minute. So one of the questions that came up with the previous presentation of the decision tables was, how applicable are these techniques in the real world, right? So as you saw, the example given, the e-commerce system, was a real-world system, right? And certainly it's interesting to think about forcing invalid stuff to happen, and to look at sequences of transitions that could occur in case the system gets confused or something. So there is a practical element to it, to these techniques. There's also sort of a fundamentals issue here too. So if you're practicing to play a sport or a musical instrument or something like that, you do a lot of fundamentals over and over again, right? If you're going to play soccer, then, or football for the international audience here, then you probably spend a lot of time just kicking a ball into a net. Now, that might only happen 2 or 3 times in a real game. Maybe you only get a chance to do it once, but you want to know that when it's time to do it, you can do it, right? Similarly, people who play musical instruments spend a lot of time playing scales, right? Going up and down the keyboard or up and down the scales of the musical instrument. You don't actually do that in a real concert, but you need to be able to do those same kinds of moves, right? So there's that element of this too, that these techniques are good in that they get you thinking about fundamentals, sequences of events and transitions, weird stuff that really shouldn't happen, but maybe it could happen, and we should understand what happens next. So I think there's a benefit of that too, just forcing yourself to think through the fundamentals of it. Another question that came up previously was the use of reactive strategies like exploratory testing or bug hunting in the context of these techniques. And that's certainly something you can do. If you're running one of these state-based tests and you see something weird happen, then by all means go off and explore the weirdness. Don't go, oh well, the next thing I'm supposed to do is this, so I can't go look at that. Anytime you see something strange happen, you want to explore it. So certainly these techniques are combinable in that way. Let's see what we got here. Question and answer pane up from the audience. This takes a minute. I got a question here from George Carter. Where your data seems to compare the actions taken by one state with actions taken by others, many times it's difficult to gather this data. In these instances, where do you obtain the source data, compare the actions, and derive a better action plan? Okay, so this seems to get to the issue of this is all well and good if somebody gives you a state transition diagram, but what do you do if you don't have the state transition diagram, right? Well, let's assume that you're developing your tests in context that would be the case, say, here at CA to start with, where you do have access to the programmers, right, and the designers. So if you have access to those folks, then presumably you can draw the diagram. You can show that to the designer or programmer and say, I think this is how this system is supposed to work. And you confirm this, and you can walk through it with them, right? And if that's